This Fathom demonstration is going to take a look at a simulation involving the distracted driver study. This is based on a distracted driving activity that's found in the Practice of Statistics 4th edition. So what is more distracting, talking on a cell phone or talking to a passenger? 48 people were randomly assigned to talk on a cell phone or talk to a passenger, and the response that was measured was whether or not the driver stopped at the predetermined rest area. And here we can see the results. 24 people talked on a cell phone, 24 people talked to a passenger. 12 of the cell phone drivers did not stop at the predetermined rest area, whereas 3 of the passenger distracted drivers did not stop. So the question is, assuming the type of distraction doesn't make a difference, what are the chances these results could actually happen? Is it likely that we could actually get 12 people not stopping? So in other words, are these results statistically significant? So to help us answer this question, we're going to take a look at a demonstration here in Fathom. And here we can see we've got a collection of Y's for yeses and N's for no's. There's 33 yeses total and another 15 no's in total for 48 observations. And what I'm going to do here is I'm going to sample some cases from this collection, but I don't want to sample 10. I actually want to sample 24. So we're going to sample 24. And you might say, well, what, is there really 24 there? Well, here we have 24 yeses and no's. Except I did not replace the existing cases. Let's try this again. There we go, 24, 24, and so on. So we have 24 yeses and no's here. So we want to count how many times no's occurred. It's 12 unusual. How many times did we get a no? So let's actually collect a measure called count. And we're going to count on the variable did stop, how many times there was a no. So in this set there's 8 no's, and in this next set we just have 10 no's. So I could keep track of those by hand, but that would be kind of annoying. So let's have Fathom do the work for us here. Let's actually collect some measures. So it's randomly generating or randomly selecting 24 observations from this group of 48 observations, and it did that 5 times, but really I'd like to do that 100 times. And we're going to replace the existing cases that are in there. Actually, before I do that, let's take a look at a table here. So we can see 7, 10, 6, 7, and 8 were the number of no's that occurred, which is 10 is kind of close to 12, but what if we collect more measures? Are we going to get 12 to occur at all? Well, let's take a look at a graph. So out of these 100 observations, 12 never occurred. So the likelihood of this happening due to chance is basically nothing. Let's try this again. So here we're building our 100 simulations, and once again 12 never occurred. Let's try it again. Oh, we got 112. So one time we had 12 observations or 12 no's occur out of a total of 300 trials that we just did. So I would say that these results are not likely to happen by chance alone, and that actually talking on a cell phone does make a difference in terms of the distraction. It is a worse distraction than talking to a passenger.